All right, welcome everybody. My name is Mike Hendrickson. I'm a senior consultant with Microsoft Consulting Services. I've worked at Microsoft for the past 9 years, the entire time specializing in Microsoft Exchange Server, a bunch of different aspects of it. The first 6 years I was with Microsoft, I worked in our escalation services and support. So I was a support escalation engineer and then an escalation engineer working on a bunch of hard cases in all sorts of different areas of Exchange. And then the past 3 years, I've been a consultant focusing on technical delivery, specifically Exchange Server architecture and design. And then my other big passion is automating Exchange and either using PowerShell, C#, anything I can do to automate the Exchange's story. So today I'm going to be talking about how to automate Exchange 2013 using PowerShell, desired state configuration, or DSC. So the primary objective for this module is going to be basically to teach you guys how to take the Exchange module for PowerShell DSC and use it to configure many different, or hopefully all aspects of your Exchange 2013 deployments. Once we do that, I'm going to walk through an end-to-end example of basically all the different possible areas you could configure using DSC. We're going to start off basically showing how to run jet stress against your servers, basically do a pre-deployment phase, how to use DSC to install your Exchange servers, and then how to do the post-configuration, which is probably the most important part. Get your CAS settings right, get your database settings right, get your databases created, and get your DAGs created and configured. And then I'm also going to cover some of the example scripts that ship with the Exchange module for DSC. There's a number of scripts examples that already exist that show you how to use all the different components. So I'm just going to point some of those out and then walk through a couple of them. So there's a couple other sessions at Ignite on DSC, so I'm not going to dig into the basics of DSC too much. I link to those DSC sessions at the end of this PowerPoint slide, so if you want to check those out at the end of the week, I highly encourage for getting more information on DSC. But DSC is a PowerShell-based management platform which was introduced in Windows PowerShell 4. So it ships with Windows 2012 R2, but you can install it going back to Windows 2008 R2. And it's kind of an alternative way to write PowerShell configuration scripts, where your configuration scripts are declarative, not imperative. And by that, I mean when you're writing a PowerShell script, you're not saying how exactly to do every single step along the way. If you want to configure a mailbox database, you're not saying run new mailbox database, set these properties, run set mailbox database. You're basically just saying for this database object, you want to configure these certain properties. And the DSC module is what is actually going to figure out what needs to be done for you in the background. One of the biggest features of DSC is the ability to prevent configuration drift. Every single DSC resource has two main pieces of functionality. They test your configuration, and then they set your configuration. So whatever parameters you've defined when you write your DSC configuration scripts, when you actually execute that script, it's going to go through and check those parameters one at a time. If any of those don't validate, then that'll trigger DSC to actually go and set the configurations. So the first time you run your configuration scripts, there's probably going to be a whole lot of work for it to do because it's going to have to go touch a bunch of different settings. When you're running subsequent iterations of your configuration scripts, they can actually be pretty quick because we only have to test the configuration, and if the configuration checks out, then we can just move on. DSC is broken up into two major components. We have DSC modules, and then we also have DSC resources. DSC modules are composed of one or more DSC resources and cover a certain area, usually a major product. For instance, there's one DSC module for configuring Exchange. There's a module for configuring SQL. There's modules for configuring networking portions of Windows, modules for configuring IIS. Within the modules, we have one or more DSC resources. And these usually relate to a single cmdlet if you're doing a one-to-one mapping between PowerShell commands, or it can relate to a configuration area, maybe a component of IIS or something like that. An example I have here is in the Active Directory module for DSC, there is an AD user resource for configuring user accounts. It can create user accounts, it can set properties on them, it can remove them. And that corresponds to the AD user commandlet within the Active Directory PowerShell module. Modules and resources are utilized via configuration scripts. And when you execute your configuration scripts, they don't actually execute on the target node right away. What happens is that they're actually compiled into MOF files that are compatible with WMI. Once you compile those, then you can either push your configuration out to your target nodes, or you can set them up with a pull server so that they'll actually pull down from a central location. For today, we're only going to talk about pushing configurations, though. And once those configurations are pushed out or pulled down, they're actually executed locally within a WMI process on the target node. And this can actually speed up your configuration scripts considerably. With standard PowerShell remoting and a lot of Exchange commandlets, running them across the LAN or especially across the WAN can be pretty slow. But when you execute a DSC script, it just pushes a little 100, 200K MOF file over the target node, and then that target node actually runs everything locally itself. So you don't have to actually cross the WAN or the LAN for many operations. So the primary topic of today's session is the XExchange module. So the XExchange module is a collection of DSC resources for deploying and configuring Exchange, 2013 specifically. The majority of the resources in the XExchange module will have one-to-one mappings with existing PowerShell commandlets. So what we were trying to do was take a set of commandlets that were very common for people to use, like set OA virtual directory, set mailbox database, set web services virtual directory, and have resources that basically map up directly to those. And for the majority of the resources that exist for the XExchange module, we took over most of the parameters too. So when you go look up those commandlets on TechNet, for any one of those ones I just mentioned, you can usually use any of those parameters in your DSC scripts. So if you already know how to write PowerShell scripts or know how to configure Exchange using PowerShell and know some of the common parameters, it's not too difficult to switch over to trying DSC. That being said, I would not recommend jumping straight into DSC if you don't have any background in PowerShell. You probably want basic to intermediate level of PowerShell skills. The more PowerShell skills you have, the easier it is to troubleshoot potential scripting issues you have, know where to look, and know what kind of issues might arise while you're running these. Now, one other thing to call out is that there is an X in front of this module name. The majority of the DSC modules that have been released by Microsoft over the past year have an X in front of them, which stands for experimental. So what that means is that these modules are not officially, they're supported on a fixed forward basis. We won't take any fixes for older modules. If we do take a fix for anything, it's going to be on by the module owner, whoever wrote the module, and it'll basically be in their own time. You cannot call in for support on the XExchange module or any other X modules. However, you can call in for support with DSC itself. So if you have actual issues with DSC, you can still get support on there. Now, there is a very big PowerShell DSC community where you can get help for this sort of stuff. And as I'm going to talk about a little later, the XExchange module is actually, along with a bunch of other PowerShell modules, have actually gone open source over the past couple weeks. So there will be a lot more ways to get changes and fixes and new features in from both inside of Microsoft and from the community. So I'm going to next cover the different resources that are in the XExchange module. And these can be broken up into a couple major categories. The biggest one is the ones that are based on Exchange commandlets. And as you can see here, these are all the ones that I'm talking about that have the one-to-one mapping between PowerShell commandlets and their corresponding DSC resources. So in this resources column, you can see they all have the MSFT_XEXCH prefix. That's basically just the standard for the XExchange module. But from there on, like the XEXCH active sync virtual directory, that maps to the set active sync virtual directory commandlet. And if we look in the categories, we can see that we have most of the configuration area of Exchange covered. We have CAS, DAG, standard Exchange server, transport server, a couple of resources. So a number of different resources you can use. And again, for the most part, I would say for 90% of these resources, whatever parameters are available in the Exchange commandlet, you can use in the DSC script. There's a couple resources that are missing them. It's basically we didn't see the need, but if we're happy to take feedback if there is a need for those. The other two groups are non-commandlet-based resources and then synchronization resources. The non-commandlet-based ones are essentially used for big parts of configuring Exchange, but aren't necessarily doing stuff directly with PowerShell. So the first one, the auto mount point resource, that's used for setting up the database and mount point structure for auto reseed. So for anyone in here that's ever configured auto reseed for Exchange 2013 before, you have to set up a pretty complex mount point structure, potentially have multiple mount points per disk. It's common to have 4 points per disk, depending on how many copies you have per database. The next resource is the xexch install resource, which is basically a wrapper for Exchange setup. And then we have JetStress and JetStress cleanup, which I'm going to cover briefly. I'm not sure if that's completely applicable to this whole room. The JetStress automation is probably more applicable to really large-scale environments where you're spinning out a lot of servers and want to do them in a very quick fashion. And then finally, we have synchronization resources. DSC allows you to set certain resources as dependent on resources that executed previous to it. And what that means is if you're configuring multiple areas of a script, you can tell DSC that you don't want these subsequent resources to execute until stuff before it has happened. So the wait for DAG resource, for instance, we wouldn't want a server to try to join a DAG until that DAG has already been created. So this resource is basically just used to check and make sure that DAG exists and give kind of a wait point in your script. So now I have just a quick example of how the resources map to existing commandlets. So you can see at in this resource block for xexch OA virtual directory, we're essentially configuring 3 properties on an OA virtual directory. We're configuring 3 types of authentication. And we can see for the equivalent PowerShell command, it's basically in the background running set OA virtual directory. We can see it still has the exact same parameters for all the authentication. The only difference is that we also have to specify credentials. Now I mentioned when our DSC configuration scripts execute, they're executing in a local process on the target node. And they also run as local system, which does not have any RBAC rights to Exchange. So for the majority of the DSC resources for Exchange, we actually have to pass in credentials of probably an Exchange org administrator or someone that's very privileged that actually has RBAC rights and can do whatever we're trying to configure. And then the next example, this one is just configuring a mailbox database object. So we can, within this configuration block, the first thing we're doing is actually creating a database if it doesn't exist. If that database didn't already exist, we would create a database with that log folder and the database path. And then we also want to set circular logging enabled on it. Now, the DSC resource itself is smart enough to figure out that you probably, if you're going to have multiple copies per database, you probably don't want to enable circular logging right away, because if you try to do that and then add more copies, it'll actually fail. So DSC will look at that database copy count. Won't actually enable circular logging until it's detected that all those copies have been added. So all you have to do is set what properties you want on it. DSC will figure out in the background how to actually go about setting those. So why DSC for Exchange? I think one of the biggest reasons to use it is because there's a bunch of pre-written scripts and examples to more easily automate your Exchange setup and configuration. If you already have a bunch of configuration scripts for Exchange, you've already gone through an Exchange deployment and have stuff to use, may not make sense for deployment. Then it would probably make sense for if you have configuration items that you absolutely have to monitor. But I think for people that don't already have an automation story, there's a lot of IP that's available for you to go out and get started with pretty easily. With DSC, not just for Exchange, but with any DSC modules, it's very easy to write configuration scripts that target multiple environments. For instance, for my customer, who I did a lot of the work on this DSC module for, they have a production forest and two pre-production forests. And then I also have my own lab that I use to test stuff out and validate it before I hand it off to them to run in their environment. So with DSC, I'm able to write one set of configuration scripts that can target all 4 of those environments. And as I'll show, we can use configuration data files to define the environment-specific information. So for instance, in the configuration scripts for all those environments, we always want to configure the same authentication settings. The things that may change are the namespaces, the server names, and we can actually just put those in separate files. It's very easy to switch between them. DSC allows you to monitor and correct certain Exchange configuration items which get reverted after applying cumulative updates. This is not something new. With Exchange 2010, certain items would get reverted after applying service packs. Exchange 2013, cumulative updates behave a lot like service packs. They actually just tear down all the binaries on the box and put them all back. So some settings are prone to getting reverted. And I have a slide that follows this that'll actually show what some of those settings are. And I also covered this, but because DSE scripts run locally on the target box, they actually run quite a bit quicker since they're not having to go over the LAN, send input and output between your admin machine and whatever machines you're running the script against. Some key features, I've already covered a couple of these. We can maintain or prevent configuration drift. We have a number of different Exchange commandlets we can maintain with this. We can automate the mount point creation and maintenance for auto reseed, and we can do the same with database and copy creation. For both of those, we have the option to take the CSVs that are output from the Exchange Server Role Requirements calculator and feed those into DSC. So for larger environments with a lot of databases or a lot of mount points on a server, it can be kind of cumbersome to actually create, to define this configuration. Using the Exchange Server Role Requirements calculator, we can let that do the work for us. And I'm actually going to demonstrate that in our end-to-end example. And then using a separate module, the X Web Administration module, we actually have the ability to maintain some different settings in the web.config files. As it relates to Exchange, a prime example is maintaining link integration with Outlook Web Access. To do that, you have to configure the web.config for OWA, and that web.config will get overwritten when you apply your updates. So using DSE, you can actually monitor that and have it set right back as soon as your updates are applied. So real quickly, I'm not going to read through this whole thing, but these are some settings that I've tested that DSE can configure that are prone to getting reverted by cumulative updates. I'm not sure how common any of these are to be used. I know I've used some of these authentication settings myself. So this isn't all the settings that are reverted by cumulative updates. These are just ones I've tested. But if anyone else has come across any and would like to provide feedback to Microsoft, we'd be happy to hear it and add those additional parameters into the resources. So how to get the X Exchange module? Up until recently, the majority of DSE modules were hosted on TechNet in a DSE resource gallery. We've slowly moved them over to PowerShell gallery, and now this is actually the primary place to go get your DSE modules. So to get the module, you have to do it from a machine with Windows Management Framework 5 or PowerShell Get. Once you have Windows Management Framework 5, you can go into PowerShell and just run install-module-name and then the name of the module. And it'll actually go out and download that from the PowerShell gallery, and it'll put it into your appropriate modules directory for you. You can see once I run this command, all DSE modules go into this path: C, program files, Windows PowerShell modules. So you'll see it show up there. Now, Windows Management Framework 5 is not currently supported with Exchange 2013. It's in a beta phase at the moment. So until it's fully supported, what you'll have to do is on an admin machine or your workstation, anywhere that has this Windows Management Framework 5, you can download the module there and then just copy it over to the exact same folder on your target nodes. Now that is just for push mode. If you're running your DSE configurations in pull mode and having them pull the configuration from a pull server, they'll actually pull down the modules too. So you could just have that module in one place on your pull server, and the target nodes would just pull it down for themselves. And they'll also maintain updates if a new module version comes out. And then finally, X Exchange, as with the rest of the X DSE resources, are now open source as of a couple weeks ago. So the most recent version of X Exchange was just posted on GitHub. It's version 1.1.0.0, and it contains a number of fixes that I've put in over the past year. So if you've downloaded the X Exchange module in the past and haven't got a recent copy, I definitely recommend getting the latest version. So you can see where the GitHub repository is. You also see if you're interested in contributing to this resource or this module or any other DSE modules, we are happy to take contributions from the community. So feel free to go to this link. There's full instructions on how to get started doing that. All right, and with that, I'm going to jump into my first demo. Okay, so this is a very simple DSC configuration script. And the purpose of this is just to basically configure two settings. We're configuring our internal auto-discover settings that are going to be handed out to domain-joined Outlook clients. Specifically, if we look down here, we're configuring the auto-discover service internal URI, and then we're also just telling what Active Directory sites this client access server is going to be authoritative for. So I'm going to actually start at the top of this script and just kind of walk through the different major components of it. So every DSC script starts with a configuration block. And this is essentially, once we finally compile our script, everything within this configuration block is what's going to be compiled and what is going to eventually be pushed out to our target nodes. So everything starts with a configuration block, and then we can give that configuration block whatever name we want. In this instance, I'm configuring auto-discover, so I just named it configure auto-discover. For Exchange configuration scripts, pretty much all of them will take a parameter. And again, that's going to be the credentials that are used to establish a remote PowerShell session to Exchange. So in here, this one takes a parameter called shell credentials. Some of the other scripts that I'm going to walk through take multiple parameters. I'll cover those as we get to them. For resources that don't ship out of the box with PowerShell, there are some built-in DSC resources, like the file resource for copying files or the package resource for installing Windows installer files. But for anything that doesn't ship out of the box, you actually have to import the DSC resource, basically to say we're going to import the module. And you can see when I'm in the PowerShell ISE, if I did not have that line there, the usage of the Exchange configuration block down here would just go blue. So if you ever see this blue in your PowerShell configuration scripts for any of your resources, either you forgot to import the DSC resource or you did not download the DSC modules to your modules folder. And then next we have our node block. And this is essentially the heart of the DSC configuration script. This is where we're declaring what resources we're going to use and what we're going to configure for any specific node. Now you can see here, after node, I have this thing called allnodes.nodename. When we're defining a configuration, we can either have our configuration target a single node. So instead of having a variable there, I could put localhost here. Or I could put my target computer's name. And when I compiled this configuration, it would apply to a single server. Now, more than likely, we're going to want to configure multiple computers at a time, be able to use this configuration for many computers. So we're actually going to use a variable here. And this is coming from our configuration data, which I'm going to cover here in just a second. The next block we have in here, which needs to be run once before ever using your Exchange credentials or trying to use Exchange credentials in your PowerShell script, is a local configuration manager section. For Exchange purposes, what this is doing is identifying the certificate thumbprint that the target nodes are going to use to decrypt credentials. When we use credentials within a configuration script, when we compile that script, the credentials are actually encrypted using a certificate that's on the local box. And that's so our passwords are not stored in plain text. If we didn't encrypt the credentials, they would basically be stored in plain text in the MOF file, which is the compilation output for this. So here, I'm basically saying on our target node, we're going to use a certain certificate thumbprint. Now, where this is actually coming from is a configuration data section. And I linked to a couple articles at the end of this session on how that get into configuration data in more depth. And this is actually covered in some of the basic DSC sessions that are here at Ignite. But essentially, we have two different blocks here. First, we have an all nodes block, and this is going to be settings that apply to all nodes. And this is essentially how we can define multiple servers that we want to configure with a same configuration script. So first, I have a single node here. I'm going to configure an Exchange server called E15-3. So when I compile this script, I'm only going to get output for a single server, for a server named E15-3. Now, I could also have additional blocks in here if I wanted to configure an additional server, E15-4. I would just put that in here. And when I actually compile it, for every node that's defined in there, it's going to loop through and spit out a configuration specifically for that node. Now, all our Exchange configurations also have a certificate file and a thumbprint. Again, these are used for encrypting and decrypting credentials. So this is actually a prerequisite for getting started working with DSC against Exchange. You're going to have to get a certificate for working with credentials. Now, the certificate doesn't have great requirements. Essentially, it just needs to be able to encrypt, do encryption. So in my lab, I use a computer certificate, which is issued from my Active Directory Certificate Authority. But essentially, I haven't come across a certificate yet that didn't work for it. So the certificate file is going to be a public key export of that certificate we're going to use, and it is going to be on the local machine where we're compiling the script initially. The thumbprint, on the other hand, is what's going to be used on that target node. So all the target nodes need to have the private key corresponding to this public key deployed into their local machine's personal store. And I've actually included a simple helper script in the demo files, which are attached to this PowerPoint presentation, that it basically shows you how you can deploy that certificate remotely from a single location. So again, going back up here, when we're specifying a certificate ID, basically we're getting it from node.thumbprint, and that's coming from the configuration data. For every single node, they're just going to look at this thumbprint that shows up under this node name equals star section. Now, when I actually compile this, to compile this script, I basically run it. If I go down here, I have a line that corresponds to the name of the configuration script. So when I run that configuration script's name, it's going to compile it and spit out some MOF files. So I'm going to go ahead and do that. And I can see that for both of the nodes we're configuring, we get a file corresponding to their name in .mof, and then also a .meta.mof. The .meta.mof only occurs when we're configuring the local configuration manager. So in my end-to-end example, we only configure the local configuration manager once. For the remaining scripts, we just configure Exchange resources. So for those, we'll only see files corresponding to the server names, not the meta.mof ones. And where this is actually spit out, so in the directory I was located, it'll actually create a subfolder, and it'll put all those MOF files. I'm going to go ahead and open up one of these. Now, I don't expect anyone to ever have to write these MOF files manually. That would be a pretty difficult task. I don't know how to do it myself. But it is good to be able to go in these MOF files and look at them, especially if you're troubleshooting an issue. You're not sure if your configuration script was executing properly. So the first thing I see in here is the credentials that was passed. And right here, the username is in plain text, but the password has actually been encrypted using the certificate. And then I actually see an instance of the client access server object that we're configuring. Here I have the AutoDiscover service internal URI and the URL I specified, and then an array for the AutoDiscover site scope. And the next things I would do to actually execute this against a computer, the first thing I have to do is do a set DSC local configuration manager. And essentially what that's doing is just telling the computer, the target node, which credentials to use or which thumbprint to use to decrypt credentials. So I'm going to go ahead and run that. The reason I have these commented, when I do my scripts, I like to be able to run it and compile it and see if there's any errors before I actually try to push out these configurations. So I don't want it to error out and then, or I made a mistake and then accidentally I just blasted a configuration against a bunch of computers. So I kind of want to compile it first, inspect what's going on, and then once I'm sure I know what I'm doing, then go ahead and execute the next steps. And then finally, to actually push out a DSC configuration, I run start-DSC configuration, and that runs your configuration in push mode. So I'm just going to demonstrate right here on my other Exchange server. We can show what the URLs are currently configured. Basically, the standard URL, just the server's FQDN, and then AutoDiscover site scope corresponding to its same Active Directory site. So when I go ahead and run this, it'll go through, and the first thing we're going to see is it's going to enter its test function. The test functionality that I spoke about before is in a function called test-target resource, and that's common for all DSC resources. So a lot of them you'll see something that says entering function test-target resource. Uh-oh. And my server must be not up right now. So I'm going to skip trying to troubleshoot this right now. All right. All right, so that concludes that demo. So next thing I want to talk about real quickly before I jump in the end-to-end example is basically the available example scripts that we have. And these are all located in the xexchange/examples folder. So if I go back to my demo machine and pull up the directory where the PowerShell modules are located. So again, these are in C program files, Windows, PowerShell, and modules. If I go into our xexchange folder, in here, we have a common folder called DSC resources, and this is actually where the code for all the DSC resources are defined. So if you ever want to dig in, try to customize these, you're more than welcome to. If you want to debug them, this is where you go. Now we have this examples folder and a number of the different examples that you can use to get started. I'm not going to talk about all of these, but a couple wants to point out. We have 2 for configuring auto mount points for auto reseed. One that shows how to do it from the calculator, and then one that shows it how to basically just manually define what database or what disks your disk structure is going to look like. We have the same thing for configuring databases. For configuring namespaces, we have 3 different examples, basically showing 3 different common ways to configure your client access servers. So a very common configuration for Exchange 2013 is just a single namespace across the board. So for that, I have a single namespace resource that shows how to do similar external URL and internal URL on all your virtual directories. Next, I have regional namespaces. This is essentially having site-specific namespaces for certain CAS and then different namespaces for other CAS. But other than that, they're probably going to have similar structure. They'll all either have internal URLs and no external URLs, or they'll all have both. And then finally, I have an example of an internet-facing site. So for this would be you have one Active Directory site where you have an external URL and an internal URL configured on your virtual directories. And all your client access from the internet is going to go through those servers and be proxied to whatever other Exchange sites you have. And then the remaining sites do not have any external URLs configured. So essentially, if anything hits Exchange servers on that other site, it has to proxy over. And then the next example I wanted to walk through is the Quick Start template. So this is actually consists of 2 different files. When we looked at the previous script, the configure auto discover script, I had actually defined the configuration data that shows all the nodes we're going to configure in line in that script. More commonly, we're actually going to have that configuration data in separate files so that we can use our script to target multiple environments. So if I look in here, I have 2 files, the Quick Start template itself and then our configuration data file. So in this Quick Start template, we basically have the same components that I already talked about. We have our configuration block, we import the Exchange module, and then we configure the local configuration manager with the certificate we want to use. In the configuration data file, this is where we define what nodes we want to configure and then our certificate and thumbprint. So to get started with this, you would basically come in here, you would get a DSC certificate first, and then you would update your path to where that public key is. You would update the thumbprint corresponding to that certificate, and then fill out all your nodes. And then from here, we can basically just start adding resources to this. So if I wanted to configure an OA virtual directory, go out here, and these actually, and these actually have autocomplete available for them, so once you start typing them in, you can hit tab and they'll fill out. And then the parameters have autocomplete for them too. So if I know identity is a parameter, I can do that. And then basic, authentication, true. And I'm not going to go through that whole example. But, so this would be a way that you can basically, this would be a starting point for any custom scripts that you want to do that don't already exist in any of the other examples. Okay, so the last thing I'm going to talk about here or walk through is an end-to-end example of how you could go from pre-deployment for Exchange all the way through having a fully configured DAG, and then get that flipped over so your configuration is consistently monitored. So for this, I broke up the deployment and configuration into 2 main phases. We have our setup and deployment, and this is all done via push mode. This is going to be the initial setup of the Exchange server and getting our initial configuration together. And there may be some troubleshooting that has to be done during this phase, which is kind of why I have broken up into different steps. Kind of gives you checkpoints to go along the way and make sure everything's good before going on to the next step. Once we get our servers fully configured, then we want to get them set up for ongoing configuration. By default, when you run a configuration via push mode, it's only executed a single time. So it'll execute once, it'll test all its settings, it'll set whatever it feels it needs to, but then it's never going to run again. What we want to do is actually put these into a different mode so that not only will it apply the configuration once, but then at a scheduled interval, it'll actually come back and recheck, and if the configuration is drifted, it'll put it back. So for the setup and deployment phase, the only ones of these that actually have to be run separately are going to be the two jet stress ones. And essentially, the reason is because when I was initially testing this, I found a potential for actually creating a jet stress loop, which is where we would install jet stress, we would validate the performance within our jet stress output, and then we would uninstall and clean up jet stress. And by that time, the script would have no idea to figure out that jet stress ever run. So if the script runs again, it would basically just do the whole thing over again. So for those purposes, I recommend putting these in two separate scripts. Now again, running jet stress isn't via DSC, isn't necessarily something you're going to want to do in small-scale environments. I really think the benefit for this one is going to be large-scale environments where you're jet stressing a lot of boxes. So these are the example environments I used in the demo. The specifics of them aren't really, don't matter a whole lot. Essentially what I just wanted to do was have a very large or a relatively large environment and then also a very small environment. The lab environment corresponds to what I actually use in my physical lab, but the production environment's just made up. Essentially what I just wanted to do here was show how I can write one set of configuration scripts and easily flip them over to target multiple environments. So before we get started, again, prerequisites for this, we need to have a certificate for encrypting our DSC credentials, and we need to deploy that private key to each target node. And then we also need to deploy any required DSC modules to each target node. And since I'm choosing, in this instance, to do my initial configuration via push mode, I would have to manually push out those modules myself. So the first thing we're going to do before we can get started is configure the local configuration manager. I'm going to switch back to the demo. So the local configuration manager only necessarily needs to be configured once. Once we've configured it once, that whatever we put in there, it'll actually stick in the target node, regardless of how many subsequent actual configurations we run against it. So for our setup and deployment phases, I essentially want to do three things. First, as with all, the previous scripts before it, we need to configure our certificate thumbprint. The next thing we're doing is setting the configuration mode. And this is actually the default setting. So if I do a get DSC local configuration manager, that is how you see the settings that are configured on a local node. I can look in, and the configuration mode is apply and monitor. And what this means is that the configuration is just going to be executed a single time, and then we're not going to try to check it again. And then I'm also setting reboot node if needed to true. Many DSC resources will set a flag indicating that a reboot needs to happen before subsequent configuration should execute. Exchange Setup is one of those. There's a couple other Exchange resources that do that. So we want to, during our setup, we basically want our nodes to be able to automatically reboot if needed during our script. Once we get to our ongoing configuration, we're actually going to flip this to false because we don't want our production servers bouncing at will if a configuration changes. We want to actually have some control over that. So as with the previous script, I would basically just compile this, and then I would run set DSC local configuration manager to push out that local configuration. I can see, as opposed to when I compiled it before, since this script only has a local configuration manager, I'm only getting meta.moff files in there. I'm not actually getting the moff files that contain our Exchange configuration. So the next section is on how to install and run JetStress. And I'm basically just going to run through these real quick, say what it does, but I'm not going to dig into the details. If anyone has any questions for this, feel free to come up and speak with me after this session or anytime during this week. I'm happy to talk about it. But essentially what these two scripts do, the JetStress script will create the mount points that are necessary for Exchange JetStress. And those are probably going to be a common configuration that you're using for all your servers. For JetStress purposes, you may just want to use one JetStress config file and then have the same disk settings for all of them. Once we've set up our mount points, what this resource does is it'll copy the JetStress files from a file server, and this is actually using the built-in file resource. So you don't have to import any DSC modules to get this. This one just exists out of the box. We use our package resource to install JetStress. We copy our ESC DLLs. When you run JetStress, you need to copy the ESC DLLs corresponding to the version of Exchange you're about to install. And that basically makes sure that you're getting the most updated performance when you're trying to validate performance on your server. We copy our JetStress config. So as a prerequisite for this, I actually went and manually created a JetStress configuration file using the JetStress GUI, and I copied it to a file server. So once I've actually installed JetStress, I want to copy that config file to the JetStress path so that it's ready to go. And then finally, we run the JetStress result, or JetStress resource. For types, this can actually do two different types of runs, either performance or stress. When you're running JetStress, performance is a 2-hour run, stress is a 24-hour run. And they'll actually spit out different types of files. So when you run a successful JetStress run, if it's a performance run, once it's finished, it'll have a performance.html file and XML file that contain basically the results of your run, whether it passed or failed, all the latencies you encountered, and how many IOPS you achieved. And that's actually what this DSC resource is going to inspect once we run it. So once it goes through and sees that a performance.html file is there, it'll actually look in it to see what the results were. Next, we specify the path to JetStress, basically the installation path. And this is essentially we're running JetStress via the command line. And then we're passing in JetStress parameters, basically just the path to our JetStress configuration file. And then lastly, we have a minimum achieved IOPS. And what this is doing is it just looking in the JetStress results to see if we achieve the IOPS, number of IOPS we were supposed to. And if we didn't, that'll constitute a failure. Now, if you do choose to use this, I don't recommend just relying on DSC's output and analysis of the JetStress results alone. You probably still want to go to all of your servers and manually inspect the results. So if DSC tells you that JetStress had a failure, then you're going to want to go on the target node and actually look at that failure. But even if it's a success, it's probably a good idea to actually go look at the report and just make sure it is what you think it is. And then for cleaning up JetStress, this script is pretty simple. Basically just uninstall JetStress using a package resource. And then we use a JetStress cleanup resource. And what this does is it looks in the JetStress config file, detects all the different databases and mount points that we had used for JetStress, and actually tears all those down if we tell it to delete mount points. We can have it copy off our JetStress reports to a central location like a file server, and we can have it remove all the JetStress files. And this would actually trigger a reboot too after this. The JetStress cleanup resource will flag a reboot, so basically after that reboot, your server would be ready to install Exchange. So the next resource, or the next script I'm going to talk about is how to install Exchange. So this one's probably a more common operation and applies to environments of all sizes. So for this one, we can see that we actually have two parameters here. We have our credentials to install Exchange, and these are going to be fairly similar, probably similar to whatever your Exchange org credentials are. I guess the exception would be if your Active Directory team, or if they're the only ones with permissions to install Exchange servers or to prepare the forest or prepare the schema. And then we also have credentials for copying files. And what we're doing here is we're actually going to copy the Exchange setup binaries locally from a remote machine, and then we're going to execute setup locally. So right here we use a file resource, and what this is doing, we can see that it's using a type of directory. And what that's doing is it's looking at all the files that are in this path, which is essentially just a path on our file server. And if I look in our configuration data file, I have two configuration data files. One Exchange settings for my lab, and then one Exchange settings for production. So if I look in here for production, I can see that we have a file server base of just fileserver1.contoso/binaries. And then for lab, I have a completely different file server altogether. But because these settings apply to all nodes, if I switch, all I have to do to switch between environments within these configuration scripts is basically change which configuration data file I'm using. So right now I'm targeted to my lab. If I wanted to switch this over to production, I would just switch it to prod. And then when I compiled it, it would look at all the settings from this production data file instead of from the lab data file. So going back up, copying our Exchange setup files from a remote file server and copying them to a local path. You don't necessarily need to do this. You could try to run Exchange setup over the network. Depending on your network setup, it may work just fine, may encounter issues. And if you do encounter failures, you would have to recopy all your setup files. Exchange setup makes use of a DSC resource called xpending reboot. Apps have a couple different ways to flag to the operating system that we want a reboot to happen before another installation can proceed. So what this resource does is basically just check if there's any pending reboots, kind of smooths out the process for Exchange setup so we don't kick off setup and then immediately have it tell us we have to reboot. And then finally, we're doing our Exchange install resource. And essentially, this is just a wrapper for command line setup. So we're giving it a path to our Exchange setup files, and then we're giving it command line arguments. Usually, it's always going to be mode install. We're going to do one of two roles or both, and pretty much everyone is going to accept the Exchange server license terms. And then we're passing in those credentials to use to install. Now, I mentioned before that DSC has the ability to set dependencies on resources. You can see that these two resources right here have a depends on block. And what we're essentially saying is, for this pending reboot resource, we don't want this resource to execute until this file resource with this name successfully executes. So that corresponds up here. And then subsequently, we can see that we don't want our Exchange installation to go until we've tried to do this pending installation. And then finally, after setup has completed, I've kind of debated where to put this resource. This is essentially its purpose is just to license the Exchange server. We're setting the product key, which requires a restart of the information store. So I put this after Exchange setup because commonly you're going to have to reboot the server, so it just gets that information store restart out of the way. And then finally, we wrap this in another pending reboot. So once setup's done and it's flagged to the operating system that a reboot is ready, then the DSC script will automatically reboot the server. By the time that server's come back up, you should have a fully installed Exchange server. So there's a couple things to note about running Exchange setup via DSC. One is that outside of that xpending reboot resource, you may see that when your Exchange install resource runs, it actually forces a reboot of the server itself before it starts setup. And when we were developing this resource, we actually encountered an issue where Exchange setup would detect that certain WinRM registry keys were missing and that they needed to be configured. And it would set those keys, and then it would restart the WinRM service. And that would actually break our DSC connection to the Exchange server. DSC script would die, but then Exchange would also hang trying to restart that service, so Exchange setup would die, and we basically couldn't get past it. So to preempt that, we basically just put this command, the same command that Exchange setup is running, in the DSC script, and if it detects those registry keys are missing, it runs this. With Windows Management Framework 5, this is not an issue, so hopefully soon that will be supported with Exchange, and this will be a non-issue with Exchange setup. In the meantime, if you want to preempt this condition, you can manually run this command. The reason you may want to do that is because when you execute your configuration in push mode, you can actually monitor all the progress that happens. But once a reboot occurs, you lose that connection, so you can no longer monitor Exchange setup. At that point, you would have to remotely monitor if Exchange setup was running, basically look for the EX setup process or something like that. And then the other a lesson I've learned with this is that using the file resource I've talked about to copy the Exchange setup files locally does not work in certain environments. I've seen it just hang sometimes. I think it's due to the large number of files within Exchange setup. So if you encounter an issue where it just can't copy the setup files locally, I recommend either pre-staging your Exchange setup files manually on the local servers, or you could just specify running setup from a network location instead. Okay, so the next script I'm going to jump into is the configure server settings one. And this is basically, for the purposes of this, it's doing mostly CAS-specific configuration. For both of our environments, we're going to configure internal URLs, which are going to be site-specific for each of the Exchange servers, and then we're also, or for all of the Exchange servers in different sites. And then we're also going to configure common external URLs. And you can see this actually uses a X Web Administration module, and that's what I'm going to use to demonstrate how to configure link integration for Outlook Web Access and to maintain settings within a web.config file. Now within this node block, we have some new variables here that haven't showed up yet. We have some DAG-specific settings, some CAS settings that apply to all CAS, and some CAS settings that apply per site. And these are actually defined within our configuration data files. So we can see here, we're actually pulling these out of configuration data. Once we're in our node block, we can map to our configuration data manually using variables like this, and then we can actually index into it. So for the DAG-specific settings, I'm going to go ahead and look in our Exchange settings-prod. And in here, I have a bunch of nodes defined, and they, besides just having the node name, they also have some individual properties that are only going to apply just to those nodes. And these node properties are names I basically just made up on my own. There's no hard requirement for what you want to do here. I basically just chose names for these. So going down to the very last server, I can see this server has a DAG ID of DAG02 and a CAS ID of Site2CAS. For the DAG ID, what this is essentially saying is that when we try to retrieve DAG settings for this node, it should look for this block down here that corresponds to DAG02. So when I actually pull in this part out of the configuration data, what I'm actually pulling in is all these variables right here that are defined for this specific DAG. Similarly, when I go and look at our CAS settings per site, for this node right here, which belongs in Site2CAS, it would actually go down here and pull all these settings out of Site2CAS. So here's where I get my site-specific namespace, my site-specific auto-discover, site-specific link server, and site-specific offline address book to connect to. Now we also have a block up here called all CAS, and for the purposes of this, it was basically just our common external namespace. So, you know, what you put in the external or the internal is going to be completely environment dependent. And we can see if I go look at my lab has completely different namespaces. So I still have a DAG01 block, I have no DAG02 block, and then I have Site1CAS and Site2CAS, but they actually have completely different namespaces, different link servers, different scopes. So what this script does, the very first thing it does is installs an Exchange certificate. Prior to running any of these scripts, I had gone on a single Exchange server and created an exportable Exchange certificate. Basically put all my auto-discover name, my Outlook Web Access name, all my namespaces on that certificate. And I made it private key exportable, and I re-exported it out with a password, so that when I do subsequent nodes, I can basically just import that in. So this file resource is essentially copying our Exchange certificate that's been exported into a PFX file to a local path on the server, and then we use the XEXEH Exchange certificate resource to install that certificate. And for this, it's actually getting the thumbprint corresponding to it from its DAG settings. Now for some environments, depending on how many servers you have, you may be able to have a single certificate for all your servers. You may have to break it up per DAG. You may have to break it up per site. For this example, I was just saying that each DAG has its own certificate, so I have a dedicated thumbprint defined for each DAG. So what this is doing, when this resource executes, it'll look for if a certificate's already installed with that thumbprint. If it's already installed, it's basically going to jump straight to the services and inspect whether those services are configured or not. And if not, it would run enable-exchange certificate with that thumbprint and enable those specific services. If the certificate didn't exist, however, and we had specified cert file path, it would actually import it. And it gets credentials right here from how we had passed them into the configuration script. So next we're going to go through and configure a number of different URLs. This first block configures the auto-discover settings, similar to the very first example that I showed. The difference here is that instead of hard-coding the URL, we're actually making it dynamic. For all servers, our auto-discover URLs are always going to start with HTTPS, and they're always going to end with autodiscover/autodiscover.xml. But the namespace within it is going to change, depending on our environment. So for here, we're pulling from our CAS settings per site internal namespace. So for a Site2 CAS server, there we go. mail-site2.contoso.com. And then that would get automatically replaced here. Similarly, we're getting our auto-discover site scope dynamically from those site-specific settings. For ActiveSync Virtual Directory, in the next couple resources, what we're doing is configuring external URL and internal URLs. And I'm going to comment right here real quick. If you actually want to have a null URL, instead of putting null in here, what you would want to do is basically just do an empty string, and that's a better way to DSE handles it better when the modules are running. But for this case, none of our URLs are null. So we're getting our external URL from our common CAS settings and our external namespace, but we're getting a site-specific URL for our internal URL. Same thing for ECP. Once we get to MAPI Virtual Directory, you'll notice that MAPI Virtual Directory has an extra authentication methods parameter in here. And essentially, when you run set MAPI Virtual Directory, it has a requirement to also specify an authentication method. So this is actually the default authentication method. This is essentially just to make the set MAPI Virtual Directory commandlet happy. OAB Virtual Directory, we're essentially just configuring URLs. Outlook Anywhere has a requirement similar to MAPI Virtual Directory, where it wants you to configure a couple other parameters. So if you want to use Outlook Anywhere, you basically have to use, or if you want to configure Outlook Anywhere, you at least have to configure the settings that are listed here. And then lastly, it's going to configure Outlook Web Access. And the first thing it's going to do is configure link integration. So what this is using the xwebconfig key value resource from the xweb administration module. And what this is going to do, it's going to go to the web.config for the OA Virtual Directory's backend website, and it's going to specify the key value pair that we have here. If anyone's configured this in Exchange 2010, essentially all we had to do was configure it on the front-end virtual directory, but for Exchange 2013, we have to do it on the front end and the back end. So what the back end wants is the certificate thumbprint that we're going to use for that link integration, and then also the name of the link server that we're going to integrate with. And then we also have to have similar settings and more on our OA virtual directory. Again, we have our server name and certificate thumbprint here, but we also have to signify that we want IAM enabled and an instant messaging type of OCS. And then finally, we configure our Exchange Web Services virtual directory. All right, so the next example I'm going to walk through is how to configure a database availability group. And you'll see that this configuration script actually has 2 node blocks. And this is the only configuration script out of all of these that do this. And essentially the reason for this is for a DSE-specific concept. When we're configuring DAGs, we have one server in that DAG that's going to maintain the configuration. If the DAG doesn't exist, it's going to create that DAG, and then once it exists, it's going to set whatever properties need to be set on it. All the remaining nodes in the DAG basically just need to join the DAG. So for this first one, we're actually, if you look in our Exchange settings again, we can see that all nodes have a role assigned to them. So usually, in my example, the first server in the DAG is the first DAG member, and all of them are additional DAG members. So when we compile this, the script will actually be smart enough to figure out that if we had the role assigned to first DAG member, it needs to go in this block. Else it's going to get its configuration from this block. So for that first DAG member, we basically just use 2 resources. First, we use the database availability group resource, and that's going to go ahead and create this DAG with all these resources or properties that we've specified. Once the DAG's been created, regardless of if it's a first DAG member or an additional DAG member, we actually have to join the DAG too. So this resource is going to use the database availability group member resource, and it's going to look for the DAG with the same name and then join that DAG. And we can see we have a depends on here. Essentially, we don't want to try to join the DAG until that DAG's been created. And then if we look in our additional DAG members, we can see that instead of creating the DAG here, these DAG members just use the wait for DAG resource. They're looking to see basically just running get-database availability group against that DAG name, and until it comes back, they're not going to go ahead and try to join the DAG. But once it does come back, they can join it successfully. All right, and the very last part of this example is how to configure the databases and the database copies. Now for these examples, I'm actually using the Exchange Server Role Requirements Calculator as input for creating both the mount points for auto reseed and also for creating the databases and copies. And I did include the calculators in this. When we're looking at the calculator, we can see that, well, let me switch over here. So for this specific calculator, this is the one corresponding to production. In that, I had actually defined 10 8-node DAGs. The Exchange Server Role Requirements Calculator lets us spit out CSV files that define what a single DAG looks like, but it won't actually let us spit out configuration files for multiple DAGs. So when I defined the names for my servers, I actually gave them fairly generic names. I'm saying in production, all our servers are going to have a prefix of SRV and a number of 01 through 08. Now, this -NN here corresponds to whatever DAG they were going to be. So they could be from any of DAGs 1 through 10. Now, by putting in a placeholder here of -NN, once I spit out those files, I can actually tell DSC to go in, and instead of looking for a definition of its specific server node, just go look for the generic definition. You know, node 1 in every single DAG is probably going to have the same database layout. They're going to have a similar mount point setup. They'll just probably have different database names and such. And we can see I do the same thing here for database, or for the database names. So all the databases are going to be DAG, dash, whatever the number is for the DAG, and then DB, and then whatever the database numbers are. And then once we go ahead and actually compile this, we can get that node-specific information in there. To be able to use the, actually one more thing to show, the way you actually get the output for this, so if we look in here in my demo files, I included the calculator file, but I also include server CSV, mailbox databases, and mailbox database copies -CSV or .csv. And these are what we're going to be using as input. To generate those from your calculator, you go to the distribution tab and then do an export DB mount list. What you actually put in here, DSC doesn't read these. These are used for some other scripting we have. But basically, just give it a path and hit OK. And then same thing for our primary DB list and our copy DB list. To actually work with those files, though, we need an additional file, which is the Exchange config helper. And for demo purposes, I've actually just copied it right into our demo directory, but this does ship with the X-Exchange module. So if we go into the X-Exchange module and we go into our examples folder, there's a helper scripts folder. And we have this Exchange config helper right there. So essentially, that just contains 3 functions that are exist to work with those CSV files. So going in here, once I get past the initial node block, I can see I'm defining a couple local variables. And these are essentially where I've converted the calculator output into DSC usable output. So the first one, the DB map, this one's going to be used for the auto mount point resource. And a couple of the parameters, we see the first thing I'm passing in is a server's CSV path. So if I go look in my environment data files, I basically defined where all those calculator output files are going to be. And these are going to apply to all nodes. So regardless of which node we're configuring, we always want to go look at those. Going back, the next thing is the server name in CSV. And this is actually how we get the unique server name out of that generic name that we put into the calculator. So for this first node in the DAG, we can see it has a server name in CSV of SRV-NN-01. So when this node hits its compilation point, it's actually going to go look, instead of looking for its own name within those files, SRV-01-01, it's going to look for SRV-NN-01. And then similarly, if I go down to the first node in the second DAG, even though it's in the second DAG, we still look for that same server definition. And then finally, we have DB name replacements we want to make. And these are defined at a DAG level. So we can see we use dagname.db name replacements. So if we look down here, for each DAG, when we're looking at our database names, we have basically a hash table that's saying every instance of NN we see in our database name, we want to replace it with 01. Or for DAG02, every instance of NN we see in our database name, we want to replace it with 02. And you can actually have multiple replacements in here. You just do a semicolon and put in another key value pair. The only catch is that if you do multiple key value pairs in there, they can be executed in a random order. So you kind of need to make sure that one replacement isn't going to conflict with another one before doing that. So as we go in here, the first thing we have to do before creating our databases is set up our mount points. So for that, we use our auto mount point resource. And this is getting the DB database map. Basically, the DB map is which database names need to go on each disk. It also defines how many spare volumes we want to have, how many disks we want to have that just have an exchange volumes mount point, but don't actually have any databases on them. And then we go ahead and loop through. Essentially, we're doing a loop, and for every database that exists on that server, we're configuring the database, or creating and then configuring the database. And we have a depends on here. We basically can't create a database until we've already created the mount points. And I'm running out of time here, so I'm going to breeze through a couple slides real quick. So a couple things to note on working with databases and copies. One, I already called this out, but if you specify circular logging on your database, it's not actually going to be enabled until all copies that you have defined have been created. Similarly, with database copies, if you're trying to add a database copy with a certain activation preference, it won't actually add until a certain number of copies have been added. For instance, if you have 4 copies of your database and you're trying to add database copy with activation preference 4, and you've only so far added 2 copies, it's going to tell you, hey, you need to add a 3rd copy before you can add this 4th copy. So DSE will actually catch that for you, and it won't try to do the add. It'll basically just orange warning saying that try to run the script later, we didn't have enough copies ready. So as a result of these, you may actually need to run your database copy scripts multiple times. So for my customer, the way we're doing this, we run our script to create the primary databases. Then we run the script to create the database copies. And for them, they have 4 copies per database. So that actually ends up usually getting activation preferences 2 and 3, but sometimes doesn't get the 4th. So we may need to actually rerun that database copy script one more time. And then once we have all our copies, we go back and run the configured primary databases one more time, and circular logging will be turned on. Some issues that you may encounter. The most common issues that I've seen are issues due to Active Directory replication. So one is if you create your database and try to mount it too quickly, you'll actually get an error that you see there, basically an Active Manager operation failed. And essentially what's happening is the information store is trying to mount the database before it can detect it in Active Directory. So there's a couple workarounds for that. One is to use the AD server settings preferred server parameter. And this is actually something I found recommended in TechNet for this error. Worked well in my customer's lab, but did not work well in production. So we had to actually move on to the next thing, which is I added a skip initial database mount parameter. And essentially what this will do is it'll create the database, but it won't try to mount it initially. And then once you've done all your copies or waited 15 minutes for AD replication, however long, you could run a command to mount those. Now, what we actually saw was that managed availability, for the most part, would detect that these databases should have been mounted and that they were not administratively dismounted, and it would actually come around and mount them for us. So in most cases, even though we didn't tell it to mount the databases, they still got mounted in the end. And then similarly, you may encounter issues if you try to have your database copies seeded and created at the same time. The AD server settings preferred server parameter is probably the first thing to try there. I think the easier solution or the more effective solution is to set seeding postpone to true. Basically, you don't want to, basically you would create your copies, wait 15 minutes, and then come along and issue a blanket command to reseed all your databases. All right, so for the ongoing configuration, I'm going to switch back over to the lab one more time. So now that the whole environment has been configured, essentially what we want to do is get this set up for ongoing maintenance. While we were doing that setup and deployment, those were basically just one-time scripts. Now we want our configuration to continuously check. So for the first parts of this certificate, as usual, we're setting our node not to reboot anymore. We don't want to have the servers rebooted automatically in production. We want that to be an admin-driven operation. We next set our configuration mode to apply and autocorrect. And this is essentially telling it that not only do we want that configuration to run once, we want it to continuously check. And what it's going to check at is this configuration mode frequency mins. This is actually the default, 30 minutes. For some environments, that's probably fine. I've heard of customers decreasing this significantly, having their configurations run once a day. Kind of just depends on how important it is to get these configurations back. So at this point, we would run this script one more time to configure the LCM on all our target nodes, and then we wouldn't have to worry about that again. And then lastly, I have an ongoing configuration script. And this is essentially just a compilation of all the post-installation scripts I had before. I just took all that stuff and put it in one file so that we can basically just execute one configuration. And another reason for that is that DSC only allows you to have one configuration consistently monitored at a time. You can't set it up, have one script that's consistently monitoring Exchange and then a whole other script that's consistently monitoring this. If you want checking, they all need to go in the same file. So the demo files for this are attached to the PowerPoint presentation, so I'm sure you've all seen, but you can download the PowerPoint slides already, and I believe they're being made available after the conference as well. So within the zip file, there's basically just a set of scripts. I have them numbered in the order I just walked through them, and a couple configuration data files. I also have a couple helper scripts here that I didn't cover, but essentially I have one for pushing out DSC modules from a local machine to one or more target machines, one for pushing out a DSC certificate to one or more machines, and then one for remotely changing the WMI quota, which I'm going to talk about in just a second. So one thing that I encountered in my customer's environment, which is fairly large, is that you may need to increase the WMI quota. By default, WMI is limited to 500 megs per process and a gig for all WMI processes. When we were configuring a large number of databases, our remote PowerShell session would actually get large enough that it would hit that 500 meg quota, and the DSC resource would fail execution with an out-of-memory exception. So the solution to that is to increase the WMI quota. And I recommend just starting with doubling that. So take the 512 to 1024 and take the 1024 to 2 gigs. And the blog there shows a way to do it with a GUI. There's a GUI tool for configuring that, but you have to do it locally on the machines being configured, which is why I have that set WMI quota helper script attached as well. And then lastly, you may see this error from time to time. Basically, your configuration won't execute, and you'll get that H result in that specific error code. And I've seen this happen, one, if you try to execute your configuration too quickly after rebooting the node. So maybe one of your previous configuration scripts required a reboot. You came up and you wanted to go right to the next script, and you would try to run it, and it would get this error. And the other thing is if you try to do it too soon after executing a previous configuration. So for the most part, the solution to this is to be patient, and it hopefully will go away eventually. I've also been able to kickstart it by restarting the WMI and WinRM processes. So some bunch of related content to check out. This is X-Exchange specific stuff, so I have the link to download the X-Exchange module. And then I have a blog series that I worked on a couple months ago, basically walking through a bunch of the stuff that we've configured or talked about today. And it goes into detail on some other topics we didn't have time for, like automating mount point setup, and also using a pull server to deploy the X-Exchange module. Here's a bunch of generic DSC links for just getting started with DSC in general. So if you're interested in learning more about DSC in general, I highly recommend checking these out. And these are the other DSC sessions that are going to be available at Ignite. So unfortunately, they're not till Friday, but there's two different sessions being put on by program managers and developers from the PowerShell team. One of them is how to write your own custom DSC resources. I believe that's the first one. And then the second one is basically utilizing DSC configuration scripts in general. And then last, I wanted to advertise that we are taking Exchange and SharePoint on-premise, where we're asking or looking for early adopters and members for a TAP program. So if you're interested in getting in our early adopter program for Exchange 2016 and beyond, we have a number of product group representatives that are here to assist you. We actually have Balachandra in the back in an orange expert shirt. So if you're interested, you can see him. You can also go to the Exchange desk in the Expo Hall. And then finally, you can go to either that link, the aka.ms link, or email our TAP program directly. And that is it for my presentation.